In this lecture, we will solve binomial theorem by using the Pascal's triangle. So let's get started. The theorem states that if you have two variables a plus b raised to the power of n, you can write them as some constant. So it is c of 0, then a to the power of n and b to the power of 0 plus c of 1. Now the power of a has increased by 1, so it's n minus 1, and b is now increased by 1, so it's b to the power of 1. The next term would be, and so on and so forth, until you reach the last term, which is a to the 0, because it's n minus n, c of n, a to the power of 0, and c of n. Now, what are the values for c of 0, c of 1, up to c of n? One of the easiest way to find these values is through Pascal's triangle. The Pascal's triangle starts with a 1 and then two ones, and then it has one boundaries. In the inside, you just have to add the two entries. So 1 plus 1 is 2. Similarly, for the next one, 2 plus 1 is 3. 2 plus 1 is 3 here as well. And we always have 1 at the boundaries. If we continue this way, 3 plus 1, 4, 3 plus 2, 6. Now 4 plus 1 is 5, 6 plus 4 is 10, again 10, and 4 plus 1 is 5. Now these values represent the answers for C0, C1, and C2. For example, let's suppose that for a cube, we have to find a plus b raised to the power of 0. This is 0, the answer would just be 1, which is the first row. But what if you have to find a plus b to the power of 1? That is simply a plus b, because the constants are just 1 and 1. So 1 times a plus 1 times b. Now for all the higher values that are is 2, 3, 4, you can just use these values. For example, let's solve a plus b to the power of 4 on the left hand side of the screen. So we'll start by applying the binomial theorem. So according to the theorem, it should be equal to c of 0, a to the power of 4. b of power of 0 is 1, so we are not writing it down here. Next, we have c of 1. And finally, c of 3. And c of 4. Now, as you can see, the exponent is 4. That means the fourth or the fifth row of the Pascal's triangle would be applicable here. Hence, the c of 0 would be the first one, which is 1. So 1 times a to the power of 4. Then c of 1 is the next one, which is 4. 4 a cubed b. And c of 2 is the next one, which is 6. And opposite we have 4 and 1. So this is how we apply the Pascal's theorem, Pascal's triangle, like a binomial theorem to solve it very quickly. Now let's say if a question asks you to find now first of all you should know the term where a to the power of 4 will appear, because if you expand it, the first term will involve a to the 6, then the second will involve a 5 b. So this is the third term where you have a to the power of 4, right? And you have to find the coefficient of the third term here. Next, you need a Pascal triangle. So up to the seventh group, because the exponent is 6. And since it starts at any equal to 0, you have to reach the seventh row. So 1, 2, 3, 4, 5, 6, 7. It looks very beautiful in terms of a triangle, so you have a beauty here. Okay, so 6, 4, and then 10, 5, 6 plus 4 is 10, and 4 plus 1 is 5. Similarly, 5 plus 1 is 6, 15, 20. So this is the last row that you are interested in. Then n equals to 1, 2, 3, 4, 5, 6. So since we have a plus b to the power of 6, these would be our coefficients. Since we're interested in the third coefficient, because a to the power of b is the third entry here, hence the answer would be 15, because 15 is the third coefficient here. Similarly, if you ask you to find the coefficient of d to the power of 4, then you have to continue expanding it. So until you get, so we know that b to the power of 4 would be the last term, and hence the 1 would be the answer. I mean, in every case, the last term have the answer as 1. So if it was e to the power of 6, the answer would be 1. And if they ask us for b to the power of 4, then you have to continue expanding. We know we'll have the cube here, and then we'll have the 4 of the very next term. So it will be 1, 2, 3, 4, 5, and the 6th term. We can also calculate it this way, because the exponent of b is 0 at the start. So 0, 1, 2, 3, 4. 0, 1 should be squared, 2, 3, 4. It should be fifth term then. So yeah, if it was a to the power of 4, it would be third term, because a starts from the 6th. But if it's b, then b starts from 0, hence it would be the fifth term. So I will just couple the fifth term, 1, 2, 3, 4, 5. It also happens to be 15. And you can see this kind of symmetry in the whole triangle. Okay? If they ask you to find the coefficient of b to the power of 4, you can just find the coefficient of a to the power of 4 as well, because the both will have the same value. So that's the trick, that is the hack which you can use to solve the question very quickly.